So when it comes to graphing a parabola, not too hard as long as you can find points that make the equation true and plot them. We have the added task of finding the focus and directrix, so we're going to have to consider what the focal length is. But what I would do to get a couple points right off the bat is first identify the vertex. Now the vertex you can just read off from the form of this equation. It's clearly going to be 2, -3. And then what I would do is, because the y plus 3 value is squared, or expression is squared, I would probably choose a value for y and solve for x, as opposed to the reverse, because this is an inverse relation of a parabola. So convenient values would be something like -1, right? If you plug in -1 for y, then that turns the left side of the equation into a 4. Dividing both sides by 4 gives you a 1 on the left side. X minus 2 equals 1, and then add 2 to both sides and you get 3. So 3, -1 is a point on this parabola. And another nice point to plug in would be -4 for y, because that also turns the left side of this actually, that's what I meant. I meant -5. -5. -5 plus 3 is -2. -2 squared is 4. Dividing both sides by 4 gives you a 1, and then adding 2 gives you a 3. So those 2 points are on the parabola. And let's just do, let's get a good 5 points for this parabola. If you plug in a 1 for a y, then the left side becomes 16. Divided by 4 becomes 4, and x minus 2 equals 4 means that x is 6. And let's see, how about -6? That's another good value for y, because when you plug that in, you also get, nope, not -6. That's not a good choice. I'd say -7. That's what I meant. -7 would turn the left side into -4 squared, which is 16. Divided by 4 gives you 4. Adding 2 gives you 6. So we can plot those points. 2, -3. There's our vertex. We've got 6, 1. We've got 3, -1. You've got 3, -5. And we've got 6, -7. Alright, now one thing I guess I could have pointed out was that you really only had to do the vertex and then 2 points on either side, because you can use symmetry. You can use symmetry, the symmetry of the parabola, to get points on either side of it. But I guess I just decided to use a more direct approach. Alright, now let's deal with finding the focus and the directrix. Now, that's going to involve finding that p-value, which is the focal length. And now in order to do that, just remember that the way this parabola is written could confuse you a little bit. If you want to find the focal width, or the focal length rather, you really want to write it like this. Alright? Again, this is an inverse relation, so ignoring shifts, we should have x by itself not squared, and the y part squared. That means that this is in the spot that 1 over 4p should be. So that means 1 over 4p is a fourth, which means p is clearly 1. And since p is 1, that means that the distance from the vertex to the focus is 1, which means the focus is located right here, and the coordinates of the focus are 3, -3. And if you go in the other direction, you'll have a point on the directrix. So the directrix must be this vertical line through, well, through that point. So the directrix would have equation x equal to 1. And now we've got everything. I use different colors for the focus and directrix because obviously they're not actually points on the parabola, but they are related to the basic definition of the parabola. So there's a graph and the focus and directrix. In this example, we're asked to write the equation of a parabola which has a focus at 2, -3, and the directrix at x equals 6. So the first thing I would note is that directrix is vertical. And since the directrix is vertical, that means that we are dealing with an inverse relation parabola. So it's going to have this basic form. Right? And the h and the k's that you didn't see when I, a few videos back when I was doing the standard form of the parabolas, those are just shifts, right? And that's going to be our vertex. So where do we go? Well, I usually like to do this graphically because to me, I just find it easier to get all this information. So that's my origin there. To get all my information visually. So we know that directrix is at x equals 6. So 1, 2, 3, 4, 5, 6. There's my directrix. I usually dash it in or use a different color. There's x equal to 6. There's my directrix. And the focus is at the point 2, -3. So here's my focus. So now what? Well, we know that the vertex lies halfway in between the directrix and the focus. So we'll use that information to find the vertex. So in this case, I didn't make it too hard on ourselves. This distance between the focus and the directrix can even be counted if you had to. It's 4, which means that if I go over 2 in either direction from the focus or the directrix, I'll get to the vertex. So now I know that my vertex, has coordinates 4, -3. Right, and that's important because it actually gives me part of my equation right away. So it should at least start like this. X minus 4 equals, we'll leave the 1 over 4p out for now, y minus -3, which would be y plus 3 squared. Now in order to find the value here, we know that's 1 over 4p, where p is the focal length. I've actually got to find the focal length from the graph. But the focal length is the distance from the focus to the vertex, or from the vertex to the directrix. So it's this distance here, which we can see is a 2. So that means that this should be 1 over 4 times 2, which should be 1/8. And now I actually have the equation of my parabola. Almost. The reason I say almost is because according to what I've written here, this parabola would be opening to the right, right? And I mean, one way to make sense of that is just to think as x values get larger, or I put it this way, as y values get larger, then x values get larger as well, is the way I have it written here, right? When y gets really big, big number squared, then x will too, and suggests that this parabola opens to the right. To make it open to the left, which it has to because we don't want our parabola actually intersecting the directrix, I would need to include a negative here, right? So the parabola really needs to be doing this. So I'm going to adjust by putting the negative in front. Okay, so I maybe in the original I should have put plus or minus up here just to be clear. So here I'll let you try this one on your own. So you can pause the video, try to find the equation of this parabola, and then unpause it. So I'm assuming you unpaused it, and if you did it correctly, you should have gotten an equation that looks like this.